In chapter number 11, thermal properties of matter. Okay, in the beginning there is some introductory part which gives some idea about the different terms. Okay, first one is that the study of thermal properties of matter by giving definition of temperature and heat. Okay, now what is temperature? It is a relative measure of, or we can say it is a relative indication of hotness or coldness of the body. A hot utensil is said to have higher temperature and ice cube to have lower temperature. This is our common observation. An object that has higher temperature than another object is said to be hotter. Okay, hot and cold are relative terms like tall and short. Okay, we can perceive temperature by touching. However, this temperature which we are just realizing is the relative degree of hotness or coldness. Okay, but if you want to measure it properly, then for scientific purpose we are measuring with different instrument like thermometer. Okay, a glass of ice cold water left on the table on a hot summer day, what will happen? It will lose the coldness, we can say, and eventually becomes warm. Okay, it means that when temperature of a body, ice, cold water or hot tea in this case, and its surrounding medium are different, heat transfer take place between the system and surrounding. If you keep the ice cold water in summer, what will happen? It will become warm. It means heat is transferring from the surrounding to the ice cold water. Similarly, if you have a cup of tea which is kept hot cup of tea in the winter, what will happen? Okay, the hot cup of tea will become cold. Okay, so heat is getting transferred from one body to the other body if there is a temperature difference. In the case of glass tumbler of ice cold water, heat flows from the environment to the glass tumbler, whereas in the case of hot tea, the heat flows from the cup of tea to the environment. So we can say that heat is the form of energy which is transferred between two or more systems or a system and surrounding by virtue of temperature difference. So heat is a kind of energy which is transferred from one object to the other when there is a temperature difference. The SI unit of heat energy transferred is expressed in joule. Okay, and the unit of temperature is Kelvin and degree Celsius, which are commonly used. Okay, there is general discussion of the property of liquid which is used with temperature to measure it in thermometer and how thermometer represent it. Now, measure of temperature is generally done by thermometer. It is calibrated so that a numerical value is assigned to a given temperature. Okay, a given degree of hotness and the coldness, a particular number is assigned. The commonly used property is variation of volume of the liquid with temperature. Volume changes with increase and decrease in the temperature. Mercury and alcohol, they are the two liquids which are mostly used in the thermometer. For the definition of any standard scale, two fixed reference points must be there. So if you want to represent or define a standard scale, then there must be 2 points from one it begins and one it ends. The ice point and the steam point of water are taken as a fixed point. These points 0 degree Celsius. Okay, that is the ice point, and the 100 degree Celsius is your boiling point of water. Okay, these 2 points are the temperatures at which pure water freezes and boils. Okay, 0 degree it freezes, 100 degree it boils. Okay, the two familiar temperature scale are Fahrenheit scale and Celsius scale. Ice point for the Fahrenheit scale is 32 degree Fahrenheit and boiling point is 212 Fahrenheit, while that is for Celsius it is 0 and 100. Okay, on the Fahrenheit scale there are 180 equal intervals between two reference points, and on the Celsius scale they are 100 intervals. Okay, now this is the relationship between temperature in Fahrenheit and temperature in Celsius. Temperature in Fahrenheit is equal to 9 upon 5 temperature in Celsius plus 32. So if you have temperature in Celsius, say you have 40 degree Celsius, then that value is substituted here. So 9 upon 5 into 40 plus 32. So 5 8s are 8 9s are 72 plus 32. So it becomes 104 Fahrenheit. Okay, this way you can convert the temperature in Celsius into Fahrenheit. Now we shall talk about the ideal gas equation. Okay, before that we have different laws, that is Boyle's law. When temperature is held constant, the pressure and volume of the quantity of gas are related. PV is equal to constant or P proportional to 1 upon V. And there is Charles' law. When the pressure is held constant, the volume of a quantity of gas is related to the temperature. Okay, so V upon T is constant, and this relationship was discovered by Charles. Okay, now if you combine these laws, okay, then we have the equation, that is PV is equal to mu R, where mu is the number of moles, or PV is equal to mu RT, which is a constant, which is our relationship, the ideal gas equation. Okay, R is a constant, it is universal gas constant, and its value is 8.31 joule per mole per Kelvin. Okay, so mu and R are constant. Mu is a number of mole, so we can say PV proportional to T. So this relationship allows a gas to be used to measure temperature in a constant volume gas thermometer. Holding the volume of gas constant, we give, or rather we have P proportional to T. Okay, thus with a constant volume gas thermometer, temperature is read in terms of pressure. Okay, so temperature is read in terms of pressure. A plot of pressure versus temperature gives a straight line in this case. Okay, now there are different scales of temperature measurement. One is a Celsius scale. If the temperature on the Celsius scale is represented by Tc, and on the Kelvin scale, okay, it is represented as T, then temperature in Celsius is equal to T minus 273.15. This is very well known to you. If you want to convert the temperature in Kelvin, then temperature in Kelvin, if I just write for you as Tk, then it is nothing but temperature in Celsius plus 273.15. Okay, this is very common. This you have used also sometimes. Okay, now the temperature in Fahrenheit scale that I have explained earlier, temperature in Fahrenheit is nothing but 9 upon 5 temperature in Celsius plus 32. Okay, now if you consider the different scales, there are 3 different scales: Fahrenheit, Celsius and the Kelvin scale. Okay, now if you have, say, it's 0 is nothing but what you call it, the ice point. Okay, and the steam point of water is 100 degrees Celsius. Now see, if you have the Celsius scale, then steam point is 100 degrees Celsius. It is 100 degrees Celsius, and 0 degrees Celsius as its ice point. Now for Kelvin scale, okay, 0 degree will be 273.15 Kelvin and 373.15 will be its steam point. Similarly for Fahrenheit, 32 degree Fahrenheit is ice point, that is our 0 in Celsius. Okay, and 212.00 Fahrenheit is a steam point, that is 100 degrees Celsius for our Celsius scale. Okay, so these three scales represent the different points which are the reference point as its ice point and steam point. Absolute 0 is also represented here, it is 0 Kelvin, then it is minus 273.15 degrees Celsius and minus 459.69 Fahrenheit. Okay, that is absolute 0 for different scales. Okay. Now we talk about the thermal expansion. It is our common experience that most substances expand on heating and contract on cooling. A change in the temperature of the body causes change in the dimension. The increase in the dimension of the body due to increase in the temperature is nothing but thermal expansion. There are linear expansion, then there is area expansion and volume expansion. In linear expansion, okay, the length increases, area expansion, then it is a two-dimensional expansion, area expands. Okay, and in volume it is 3D. Okay, so volume is getting expanded. Okay, when say you have some rod whose length is L, okay, initial length is say L, okay, and slight increase is there, that is delta L. This increase is directly proportional to the original length and the change in temperature, and if you just remove this proportionality constant, then delta L is equal to alpha L, that is a constant for linear expansion, L into delta T. Okay, so this equation can be written as delta L upon L, alpha L into delta T. Now there is two-dimensional change, then this becomes 2 alpha L. Okay, because length and breadth both are changing. Okay, so delta A is proportional to initial area and change in temperature. Similarly for volume, this delta V is directly proportional to original volume and change in temperature. So it is three-dimensional change, therefore we write 3 alpha L. Here it is 2 alpha L and here it is 1 alpha L. Okay, try to watch this 2-3 times and try to understand the different topics. Okay, thank you very much.